Good day everyone, I am Jelica Xavier from BSED Mathematics 3A. And for today's video, we're going to tackle about the principles of mathematical induction as part of the topic of our course Problem Solving, Mathematical Investigations, and Modeling. When it comes to induction in mathematics, we intend to reach to proofs and conclusions that help us in a better understanding of theorems and examples. Deductive reasoning is based on logic and understanding, while inductive reasoning depends on the study of a particular case and observing incidences leading to that case. The principle of mathematical induction is used in algebra or other streams of mathematics that involve the formulation of results or statements in terms of n. To prove the basic principle behind n, which is a positive integer, we use a set of well-established and well-suited principles in a specific format. The techniques used to prove statements with regard to n are known as principles of mathematical induction. According to the principle of mathematical induction, the following two conditions must be satisfied. First condition is also known as the base case. The statement is true for n is equal to 1. n is equal to 1 represents the first term, and p is a propositional statement that has a definite value. This value can be true or false. The second condition is also known as inductive case. If the statement is true for n is equal to k, where k is a positive integer, then the statement is also true for all cases of n is equal to k plus 1. This assumption that we make, the statement is true for n is equal to k, is called inductive hypothesis. As you can see, we have three steps presented on your screens. First step is to verify if the statement is true for n is equal to 1. For example, p of 1 is true. The second step is to assume that the statement is true for n is equal to k. For example, p of k is true. And the third step is if the statement is true for n is equal to k plus 1, then the statement is true for all values of n. And so let us have a proof or an example to discuss the topic further. Among the properties presented on your screens, we'll prove the first one using mathematical induction. 1 plus 2 plus 3 plus up to n is equal to n multiplied to n plus 1 over 2, where n is greater than or equal to 1. And now we will start first with the first condition, which is the base case. Let us check first the base case, n is equal to 1. We'll be going to check for n is equal to 1 if the left-hand side and right-hand side is true. The first term happens to have the value 1, so let's put 1 to check the left-hand side. For the right-hand side, we have n multiplied to n plus 1 over 2. And now we will check to see if the right-hand side is equal to the left-hand side. So we will replace the n with 1 since n is equal to 1. 1 multiplied to 1 plus 1 over 2 is equal to 1. 1 plus 1 is just equal to 2. So 1 multiplied to 2 over 2 is equal to 1 times 2 is 2 over 2. And this is just equal to 1. And so the left hand side is equal to 1 and the right hand side is also equal to 1. Therefore, it is a true statement. The first condition is satisfied. Next is we will assume that the statement is true for n is equal to k. 1 plus 2 plus 3 up to k, we will replace the n to k since n is equal to k, is equal to k multiplied to k plus 1 over 2. And also we will show that it is true for n is equal to k plus 1. We will do this based on this assumption: 1 plus 2 plus 3 up to k is equal to k multiplied to k plus 1 over 2. So we have 1 plus 2 plus 3 up to k and then we will add more, plus k plus 1 is equal to, since we will replace the n to k plus 1, we will have k plus 1 multiplied to k plus 1, then it is plus 1, so plus 1 over 2. As you notice, this part is the same as here. We'll replace it with the right hand side of this assumption. So we will have k multiplied to k plus 1 over 2 plus this k plus 1 is equal to k plus 1. Then this k plus 1 plus 2, we can have this as k plus 2. So we will put k plus 2 over 2. And now we will check if the left hand side is equal to the right hand side, which is k plus 1 multiplied to k plus 2 over 2. As you can see here, there is the denominator of 2. And this one, obviously, it is over 1. So basically, we'll do the math. We will find the LCD. We have the LCD of 2. So we have now this k multiplied to k plus 1 over 2 plus 2 multiplied to k plus 1 over 2 is equal to k plus 1 multiplied to k plus 2 over 2. As you notice in this part, k plus 1 plus 2 multiplied to k plus 1 over 2, we have a common binomial of k plus 1. So we can factor it out, this k plus 1. So we have k plus 1, and we are left with k and 2, k plus 2. So we have k plus 2 over 2. And so based on our solution, we can see that this k plus 1 multiplied to k plus 2 over 2 is equal to the right hand side of this assumption, which is also equal to k plus 1 multiplied to k plus 2 over 2. Therefore, we can say that the left hand side of p of k plus 1 is equal to its right hand side. This means the p of k plus 1 is true, and the proof is completed. Hence, by the principle of mathematical induction, we can say that p of n is true for all the natural numbers n. And so we are done with our video discussion. I'll see you next time. Thank you for watching and listening. God bless us all.